Okay, so we are solving triangles, any triangle, and that means finding all of the angles and the lengths of all of the sides using some new tricks that we have, some new information. One of them being the law of sines. And we just learned when we run into problems applying the law of sines, there's something else called the law of cosines. And the law of cosines, it ends up being a long equation. C squared equals a squared plus b squared minus 2ab cosine c. But it's really valuable when law of sines is not going to help us come up with one good bit of information using the law of cosines. Then pretty much we can go back to the law of sines or back to our understanding that all of the angles in a triangle add up to 180 degrees. And so it's good to kind of jumpstart the process of solving a triangle. One of the situations that we didn't look at yet is when we're given three sides of a triangle and we're asked to solve it. So no angles are given, and three sides is actually enough to know that we have one specific triangle. It was called side, side, side back in our geometry days. But we're going to see that even though the law of cosines is not set up directly to solve for this, we can do a little algebra and rearranging, and we can use it to get an angle. And once we get an angle, then we can go back to the law of sines. So let's write down an example. I drew a triangle up there. I labeled it ABC. I just did that before I knew any information, so there's a good chance it's not drawn to scale. And the information I'm given is this: no angles. Side A is 6. Side B is 9. And side C is 4. And I can clearly see this is not drawn to scale because it looks like side C is the longest side of this triangle, and yet I've labeled it as length 4. So again, not drawn to scale, but let's use the law of cosines. Now, what we want to do usually when we don't have any angles is we kind of want to go after the largest angle. And how do we know what's the largest angle? Find the longest side. Opposite the longest side is the largest angle. So B, length 9, is the longest side. I'm going to go after angle B. So here's what I'm going to write out. I'm going to write B squared equals A squared plus C squared minus 2AC cosine B. That's going to be our unknown over there that we're going to solve for. And we could do some rearranging right now to solve for that before I put any numbers in. I'm a little concerned just about doing our algebra correctly. I find in this case it might actually be easier to drop some numbers and some values in first. So let's do that. B is 9. B squared then is 81, right? Equals A squared, 36, plus C squared, 16, minus 2 times 6 times 4 cosine B. All right. Now, here's where actually let's do the 2 times 6 times 4. I want to show you where some students are prone to make an algebra mistake that I don't want you to make. And so 81 equals 36 plus 16 minus. Now, I can multiply here because multiplication comes before any addition or subtraction. And 6 times 4 is 24, times 2 is 48. So I have 48 cosine B. Here's the mistake that sometimes gets made. Students are tempted over on the right side of this equation to say 36 plus 16. And by the way, that's all correct. I can do that addition because there's nothing else tied to it. And then they do minus 48. That's the part that's going to get us in trouble because look, this 48 is times by something. There's multiplication, and that has to be done before we do any addition and subtraction. So it's legit for me to add 36 and 16 And then I probably have to move that out of town. Let's just do this. 81 equals 36 plus 16, I believe, is 52. Hopefully I didn't get that one wrong. Again, don't subtract here. I can't subtract 52 minus 48 because it's 48 cosine B. And so I can't do that. So what can I do? Well, this 52 is like a term all by itself. I can move that out of town. I can use subtraction. So I'm going to subtract 52 from both sides. And what does that get me? 29 equals negative 48 cosine B. All right. Now I want cosine B by itself. I'm trying to isolate my variable. So I'd like to divide both sides by negative 48. Over here I have 29 divided by negative 48. I can see this is going to be a negative value equals cosine B. I know cosine B equals that. I don't want cosine B. I want to know what the angle is that has that cosine. And so I do a backwards or an arc cosine. And I can leave this fraction right as it is, so I don't have to worry about rounding off. I'm going to do arc cosine, or what's the angle whose cosine. Bad time for my calculator not to work. The angle whose cosine is 29 over negative 48. That's going to tell me angle B. And while my calculator is not working right now, I think I have that answer written down here. It turns out angle B is 127 degrees. Rounded off to the nearest degree. So finally, I used the law of cosines to get one angle. I didn't have any angles. Now I have one. 127 degrees. Remember, I went after my biggest angle. That's an obtuse angle. And I set up the law of cosines, even though I knew this information. I knew this. I knew this. The only thing I didn't know was angle B. So I had to rearrange a little bit. I think you guys can handle that. And if you mess up once, you'll probably catch your mistake and not make that mess up again. And so all of that to find out that angle B is 127 degrees. Now look, I've got a pair of angle and opposite side, and I can use the law of cosines to go after either of the other angles. Let's say B over sine B equals A over sine A. Right now, if I wanted to solve this before I put numbers in, the thing that I don't know is sine A. And so I'm going to use the upstairs downstairs rule. It would say sine A equals A sine B over side B. Sine A equals A sine B over side B. And now we're just going to plug in. We'll find out what the sine of A is. And again, sorry that my calculator is broken. You should get something approximately 0.5324. And when we get that number, we will do arc or inverse sine, and we find out that the length, or excuse me, the measure of angle A, when we do the arc sine, the measure of angle A is 32 degrees. Okay, make sure when we're doing the law of cosines, everything is cosine. And when we had to do the arc function, we did arc cosine. When we're doing the law of sines and we have to find the angle, we'll do arc sine. And so I come up with a measure of 32 degrees for angle A. And the only thing I don't know is angle C. So now I have a choice. I could do, goodness, you could do the law of cosines again if you really wanted. You could do another law of sines, or to me, simplest is saying, oh, all three angles have to add up to 180 degrees. And so I'm just going to do a little math and find out that this is about 21 degrees. And my triangle is solved. Again, it wasn't a right triangle, so I was a little more limited. Law of sines a little simpler than law of cosines, but it wasn't going to get me started. I needed something a little extra. So we used the law of cosines to get us started, switched over to the law of sines, finished up by adding all of the angles up to 180. And we've got ourselves a solved triangle. Last thing from this unit, and you can look at this in your notes, it's just a formula I wanted to give you. So it's just a matter of you practicing the formula. The formula is known as Heron's formula. In some math books, it's also known as Hero's formula. They just leave that N off. It's known both ways. And it's another way to find the area of a triangle if we only had the three sides, don't have any angles, and we just want the area. We don't feel like solving it and doing all the law of cosines. And so we can do Heron's formula. And the only thing that I have to teach you or I have to learn is what we mean by a semi-perimeter. And I hope some of you might know that the word semi means half. And we know what the perimeter is to add up all of the sides. And so it's exactly what it sounds like. A semi-perimeter is half of the perimeter. So for this triangle up here, 6 and 4 is 10, and 9 is 19. The perimeter is 19. The semi-perimeter would be 19 over 2, or 9.5. And so Heron's formula, as you can see in your notes, is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. All right, I multiply the semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, all of those, and take the square root, and you actually have the area of a triangle. It's a really cool way to do it. And I just want you to practice a couple by plugging in those numbers, seeing that you can work your calculator. So go ahead and work through the homework questions I asked you to do on page 699, numbers 1 through 10. That's all of them. We're not just doing the odd ones. It's only 10 questions. And then also 25 and 30, which are some opportunities to practice Heron's formula as well. And we'll talk about any questions that you have.